In this video, we'll be interpreting Schrödinger's wave equation. It seems hard, but we'll break it down. Let's start. First, we'll use the famous energy equation, which is the kinetic energy plus potential energy equals the total energy. Multiply that by ipsi, we'll get K ipsi plus U ipsi equals E ipsi. We know that psi in a simple wave is a e power negative I omega t minus kx. That wave propagates in the positive x direction. We know previously that E equals hf. H is Planck's constant and f is frequency. Multiply by 2 pi and divide by 2 pi, we'll get E equals h bar, which is h over 2 pi, and 2 pi f is omega. So omega equals E over h bar. Then P, which is momentum, equals h over lambda, which is the wavelength. Multiply by 2 pi and divide by 2 pi, we'll get that P equals kh bar. K here is the wave number, which is 2 pi over lambda, and h over 2 pi is h bar, as stated previously. Now we'll get that K equals P over h bar. We'll substitute in the previous equation, we'll get psi equals A, which is the amplitude, multiplied by E power negative I. We'll substitute by E over h bar in omega's place, and by P over h bar in K's place. Next, we'll get the partial derivative of psi with respect to t. We'll get negative I over h bar E A times e power negative I e over h bar t minus p over h bar x. And that equals negative I over h bar E, which is the energy, times psi. We want to get E psi in one side. That will give us E psi equals h bar I times partial psi partial t. If we return to the equation we started with, we could replace E psi with h bar I partial psi partial t. Now, let's get partial psi by partial x. That will give us negative p times negative I over h bar psi, which equals ip over h bar times a e power negative I e over h bar t minus p over h bar x. Now let's get partial square psi by partial x square. That will give us I square p square over h bar square times psi, which equals negative p square over h bar square psi. That equals negative p square over h bar square psi. We'll divide both sides by 2m. We'll get negative h bar square over 2m partial square psi by partial x square equals k times psi. K, which is the kinetic energy, equals p square over 2m. Now, for the second time, we could substitute in our first equation. We could replace k psi by negative h bar square over 2m times partial square psi partial x square. We'll get h bar square over negative 2m multiplied by partial square psi partial x square plus u psi equals h bar I multiplied by partial psi partial t. And that's the interpretation of Schrödinger's wave equation in one dimension.